Let's get to it. Number 10. The Moai of Easter Island. In 1722, Dutch explorer Jacob Roggeveen made landfall on a tiny speck of land in the middle of the Pacific Ocean, thousands of miles from the nearest continent. It was a desolate place, largely treeless and home to a small, isolated population. But standing guard along the coastline were hundreds of massive, stoic faces staring inland. These weren't just statues, they were monoliths of compressed volcanic ash, standing up to 33 feet tall. The explorers were baffled. How could a society with no draft animals, no wheels, and barely any timber transport these gargantuan idols across miles of rugged, uneven terrain? There are 887 known moai statues. While the average is a respectful 14 tons, the largest erected statue, known as Paro, weighs a staggering 82 tons. These weren't carved on the coast. They were born in the Rano Raraku quarry, an extinct volcano crater, and then transported up to 11 miles away. For decades, archaeologists argued over the method. Did they use wooden sledges and rollers? If so, where are the trees? Pollen analysis suggests the island was once lush, implying the Rapa Nui people cut down every single palm tree to build the rollers, committing ecological suicide to move their stone gods. But the sheer friction of dragging 82 tons of dead weight over volcanic rock without steel axles is a logistical nightmare that makes modern heavy haulage experts sweat. The Rapa Nui oral history insists on a different answer. They say the statues walked into place, powered by mana or spiritual energy. Surprisingly, modern experiments have vindicated the walking theory, not with magic, but with physics. By using ropes to rock the statues side to side, a team can shuffle the massive weight forward, like moving a heavy refrigerator. It's a brilliant solution, but it requires hundreds of coordinated people and dangerously flat terrain. The twist is that their obsession with these idols likely led to their collapse. They proved that with enough religious fervor, you can move mountains, but you might just destroy your world in the process. Number 9. The Olmec colossal heads. The year is 1862. A plantation worker in Veracruz, Mexico is hacking through the dense jungle when his tool strikes something hard. Thinking he's found an overturned iron kettle, he starts to dig. He digs for hours. He doesn't find a pot. He unearths a face the size of a minivan, with thick lips, a broad nose, and a grimace that has survived 3 millennia. This was the first discovery of the Olmec colossal heads, the distinct signature of the mother culture of Mesoamerica. Before the Maya or the Aztecs, the Olmecs were doing things that shouldn't have been possible in a jungle environment. 17 of these heads have been found, carved from single boulders of basalt. They weigh up to 40 tons. That's roughly 20 mid-sized cars crushed into a ball. The quarry for this specific basalt was in the Tuxtla Mountains, over 60 miles away from where the heads were found. This wasn't a road trip on a highway. This was a 60-mile trek through crocodile-infested swamps, dense rainforests, and winding river networks. The Olmecs had no beasts of burden, no horses, no oxen, just human muscle. To move a 40-ton concentrated load through a swamp without it sinking into the muck requires a level of geotechnical engineering that is hard to comprehend. The leading theory is that they used massive wooden rafts to float them downriver. But have you ever tried to balance a 40-ton round boulder on a primitive wooden raft in a current? The center of gravity is a disaster waiting to happen. If one slips, it's gone forever. The fact that 17 arrived safely suggests they didn't just get lucky. They had mastered buoyancy and leverage in a way we rarely give them credit for. They moved these mountains not because it was efficient, but because power isn't real unless you can make the impossible look easy. Number 8. The Colossi of Memnon. In the days of the Roman Empire, tourists flocked to Thebes in Egypt, not to see the pyramids, but to see a statue that sang. They called it the Colossus of Memnon. At dawn, a mysterious sound would emanate from the stone, a cry to the goddess of the dawn. While the singing was likely a physical anomaly caused by evaporation in cracks, the real miracle is the stone itself. These are 2 massive depictions of Pharaoh Amenhotep III seated on his throne. They have sat there for 3,400 years, watching empires rise and fall, silent sentinels of a level of engineering that borders on the absurd. The stats on these statues are terrifying. Each one is carved from a single block of quartzite sandstone. They stand 60 feet high and weigh an estimated 720 tons each. And they weren't quarried nearby. Geology tells us this specific quartzite came from El Gabal El Ahmar near modern-day Cairo. That is 420 miles away. They moved two 720-ton blocks, plus the hundreds of tons of rough stone originally attached before carving, 420 miles overland. They couldn't float them on the Nile because the blocks were too heavy and the water draft too shallow. They dragged them. 720 tons is the weight of a fully loaded offshore oil rig platform component. Moving that on sand requires a roadbed that won't deform and a sled system that won't disintegrate under the pressure friction. It is a scale of transport that modern heavy lift companies planned for years to execute. The singing eventually stopped after the Romans repaired the statue, silencing the anomaly. But the silence of the engineers who figured out how to drag a mountain across half of Egypt is the loudest mystery of all. Number 7. The Stonework of Puma Punku. High in the Bolivian Andes, 13,000 feet above sea level, the air is thin and the landscape is barren. Here lies Puma Punku, part of the Tiwanaku complex. Unlike the organic, rough-hewn look of other ancient sites, Puma Punku looks like a catastrophic explosion at a modern prefab concrete factory. It doesn't look ancient, it looks industrial. When the Spanish conquistadors first saw it, they didn't think the locals built it. They thought it was the work of demons or gods who had descended from the sky. And when you look closely at the stones, you start to understand why the ancient alien theorists love this place so much. The controversy here isn't just the weight, though some blocks weigh 130 tons, it's the precision. The stones are gray diorite and andesite, incredibly hard rock classes, yet they are cut with laser-like 90-degree angles, smooth as glass. There are H-shaped blocks that interlock with a precision that suggests mass production. There are drill holes so perfectly spaced and routed they look like they were done with a CNC machine. The quarry is 6 miles away, down a steep drop. How do you drag 130 tons up a mountain at an altitude where simply walking makes you breathless? Mainstream archaeology says they used stone hammers and sand for abrasion, grinding away for decades. But look at the inner cuts, perfectly sharp internal corners that are nearly impossible to achieve with a round stone hammer. The precision implies a blueprint, a standard of measurement, and a tooling capability that seems to have vanished from the historical record. It feels less like masonry and more like molding, as if they could soften the stone at will. Whatever happened here, the technology didn't just evolve, it seems to have arrived, perfected, and then disappeared. Number 6. The Walls of Sacsayhuaman. When the Spanish arrived in Cuzco, Peru, they found a fortress overlooking the city that terrified them. It wasn't the warriors, it was the walls. Sacsayhuaman is a marvel of Incan engineering that defies the standard logic of masonry. The Spanish tore down the temples in the city to build their cathedrals, but they left these walls largely intact. Why? Because the stones were too big to move and the structure was too strong to break. This is the ultimate example of polygonal masonry, a puzzle made of boulders where no two pieces are alike. These aren't bricks, these are irregular, massive limestone blocks, some weighing over 100 tons, shaped to fit together like a chaotic jigsaw puzzle. The fit is so tight that even today, 500 years later, you cannot slide a single sheet of paper between the joints. There is no mortar. The strength comes from the interlocking geometry. When an earthquake hits, and they hit Peru often, the stones dance. They shake, settle back into their perfect grooves, and the wall stands, while Spanish colonial buildings crumble to dust. The quarry was 2 miles away, requiring the stones to be dragged up and down steep Andean ravines. The standard explanation is labor tax, thousands of citizens paying their dues to the empire through brute force dragging. But brute force doesn't explain the scribe-like fit of a 100-ton, 12-sided stone against its neighbor. They didn't just stack rocks, they understood the physics of seismic waves better than we do. They didn't fight the stone to make it square, they respected the stone's shape and made the wall flow like water. It's a level of harmony with nature that modern engineering, with all its straight lines and concrete, has completely forgotten. Number 5. The Lintels of Stonehenge. The Salisbury Plain in England is home to the most famous pile of rocks in the world. We've all seen the pictures. We know about the blue stones that were transported 150 miles from Wales, a mystery in itself. But the real engineering miracle of Stonehenge isn't the distance, it's the elevation. Look at the Sarsen circle. Those massive horizontal stones, called lintels, are resting on top of the vertical uprights. It's one thing to drag a rock across a field. It's an entirely different beast to lift a 30-ton slab 20 feet into the air and place it gently on a target. The lintels weigh around 30 tons each. The builders, Neolithic Britons around 2500 BC, had no pulleys, no capstans, and definitely no hydraulics. Yet they not only lifted these stones, but they also engineered them. The lintels are curved to create a perfect circle. They're attached to the uprights using mortise and tenon joints, a ball and socket technique usually reserved for woodworking, not megaliths. They also used tongue and groove joints to lock the lintels together end to end. They were treating 30-ton boulders like IKEA furniture. The most plausible method is the timber cribbing technique, building a pulleyed wooden platform, rolling the stone up a ramp or levering it up inch by inch, adding layers of wood underneath until it reached the top. But imagine the sheer risk. One slip, one rotten log, and 30 tons of sandstone comes crashing down, crushing the workforce. It represents a society that valued time differently than we do. They spent generations on a project they might never see finished, creating a celestial clock that still keeps perfect time today. Number 4. The Great Pyramid's Grand Gallery. We can't talk about impossible structures without visiting the heavyweight champion, the Great Pyramid of Giza. But forget the external blocks for a moment. The real mind-bender is hidden deep inside. To reach the King's Chamber, you have to ascend the Grand Gallery, a narrow, soaring, core-belled hallway. Above this chamber lies a series of relieving chambers designed to keep the pyramid from crushing the burial room. And inside those chambers are massive granite beams that create a ceiling and stress relief system. These granite beams weigh up to 80 tons each. They were quarried in Aswan, 500 miles away. But the issue isn't the river transport, it's the placement. These beams are situated 150 feet above the desert floor, deep inside the solid masonry of the pyramid. The grand gallery leading up to them is steep and narrow. There is virtually no room for cranes, levers, or large teams of men to pull ropes. How do you maneuver an 80-ton beam, the weight of a locomotive, up a narrow incline and place it with surgical precision hundreds of feet in the air? Architects have proposed internal spiral ramps or massive external counterweight systems. Some suggest the machinery used was just a brilliant application of sand and gravity. But the truth is, the architect, Hemiunu, took the blueprints to his tomb. We are looking at a ship-in-a-bottle trick, but the bottle is stone and the ship weighs as much as a Boeing 757. It forces us to ask, did they know something about leverage that we missed, or were they just that much stronger than us? Number 3. The Unfinished Obelisk. Sometimes the greatest evidence of ancient capability is found in their failures. In the stone quarries of Aswan, Egypt, lies a sleeping giant. It is a single block of granite that was intended to be an obelisk, dwarfing anything else ever erected. It was carved directly out of the bedrock, but during the process, a massive crack appeared, and the project was abandoned. It remains there today, attached to the earth, a frozen moment in time that reveals the terrifying ambition of the Egyptian engineers. If finished, this obelisk would have stood 137 feet tall and weighed a staggering 1,200 tons. That is the weight of 3 fully loaded 747 jumbo jets, and they planned to move it. The quarry marks show they were using dolerite balls, hard stones, to pound the granite dust away hour after hour, year after year. The plan was likely to undercut it, snap it free, and then drag it to the Nile. We struggle to lift 1,200 tons today with our absolute best, strongest dual crane setups. They were going to do it with palm fiber ropes and wet sand. The sheer audacity is chilling. They didn't look at a 1,200-ton mountain of stone and see an obstacle. They saw a monument. The crack that stopped them wasn't a failure of engineering. It was a failure of the material itself. The stone gave up before the humans did. It serves as a reminder that their only limit was geology, not will. Number 2. The Western Stone. Jerusalem is a city of layers, history stacked upon history. The Temple Mount is the focal point, a massive platform built by King Herod the Great to expand the Second Temple complex. Today, the visible portion is the Western Wall, the holiest site where Jews can pray. But if you go underground, into the Western Wall tunnels, you travel back in time along the massive retaining wall, and there, in the dim light, you run into a single stone that defies logic. It makes the blocks in the pyramids look like dice. This is the Western Stone. It is one solid block of limestone. It is 44 feet long, 10 feet high, and roughly 12 feet deep. The estimated weight is 570 tons. It is one of the largest building blocks in the world, and it is not sitting on the ground. It is part of a wall course, lifted and placed above other stones. Herod's engineers moved this monster from a quarry likely miles away to create a foundation that would not move. There is no room here for the long ramps used in Egypt. The terrain is hilly and urban. The precision of the cut means it sits flush against the other stones without mortar. How did they generate the force to move 570 tons in such a confined space? It was likely moved on rollers with oxen and thousands of men using a system of pulleys and capstans that pushed the limits of Roman-era technology. It stands as the literal bedrock of faith, a stone so heavy that history itself seems to revolve around it. Number 1. The Trilithon of Baalbek. And now the undisputed heavyweight champion of the ancient world, the place that makes Giza look like a practice run. We are in Lebanon, at the Temple of Jupiter in Baalbek. The Romans built a massive temple here, but the platform they built it on is the real mystery. At the base of this temple lie 3 stones known as the Trilithon. They are the largest stones ever used in construction on Earth, and frankly, they shouldn't be there. Each of these 3 limestone blocks weighs an estimated 800 to 1,000 tons. Let that sink in. 1,000 tons, lifted 20 feet into the air and placed on a foundation of smaller stones. They are fitted so perfectly that you cannot fit a needle between them. Nearby in the quarry lies the stone of the pregnant woman, which weighs 1,200 tons, and a newly discovered block underneath it that weighs 1,650 tons. The Romans had cranes, yes, but Roman cranes were designed to lift 5 or 10 tons, maybe 100 tons if they ganged them together, not 1,000. This discrepancy has led many scholars to suggest that the Romans didn't build the foundation, they found it. They found a platform built by an older, far more capable civilization and built their temple on top of it. If the Romans did move it, they used a technology or a method of mechanical advantage that has been completely lost to time. The Trilithon stands as the ultimate impossible lift, a silent testament to a time when humanity was capable of feats that we, with all our silicon and steel, can still only dream of. Number 0. The Kailasa Temple. We have talked about lifting, dragging, and stacking, but the greatest engineering feat in history might not be about moving stone at all. It's about removing it. In the basalt cliffs of Ellora, India, there is a structure that shouldn't exist. It isn't a building constructed on the ground. It is a megalith carved out of the ground. The Kailasa temple was not built, it was revealed. The ancient architects started at the top of a mountain and dug straight down, carving a freestanding multi-story temple complex out of a single solid rock face. The scale of the removal is mathematically offensive. Conservative estimates say 200,000 tons of basalt were excavated. More liberal estimates push that to 400,000 tons. Legend says it was completed in just 18 years. Let's do the math on that. To remove 400,000 tons in 18 years, working 12 hours a day, 365 days a year, the workers would have to quarry, lift, and remove 5 tons of rock every single hour without a single break for 2 decades. And they didn't just remove it, they carved intricate statues, pillars, and secret passages as they went. One mistake, one slip of the chisel, and the entire monolith is ruined. There is no undo button in basalt. Historians attribute this to the Rashtrakuta dynasty, using simple hammers and chisels. But where is the debris? Excavating 400,000 tons of rock creates a mountain of rubble. Yet there is no significant pile of basalt jets found nearby. It's as if the rock was vaporized. The Kailasa temple stands as the ultimate counterargument to primitive tools. It wasn't construction, it was a 3D printer running in reverse, executed with a perfection that implies they weren't chipping away at the rock, they were melting it. So here's the question that keeps me up at night, and I want you to answer it down below. Are we looking at the work of millions of slaves breaking their backs for a god king, or are we looking at the remnants of a technology we have forgotten? Are these simple levers and ropes, or is there a missing link in human engineering that we are too arrogant to admit? Type muscle if you think it's just brute force and time. Type machine if you think history is lying to us. Let the war begin in the comments. I'll see you in the next one.